It is 7:45 Zulu time over the northwest Black Sea, near the operational boundary of the Crimean Peninsula. Just minutes ago, a pre-dawn stillness was broken above the Boiko Towers gas infrastructure complex, a hardened Russian forward operating base, as Ukrainian reconnaissance identified a confirmed threat signature. The analytical goal of this narrative is to dissect the procedural discipline and asymmetrical technological leverage employed during the neutralization of this complex. We are analyzing the sensor-to-sensor engagement and tactical application of unmanned surface vessels, USVs, and first-person view, FPV, Unmanned Aerial Systems, UAS, against a fixed, air-defended coastal asset. The Boiko Towers, originally civilian energy assets, had been transformed into critical forward observation posts, projecting Russian surveillance across key shipping lanes approaching Odessa. The primary function of this steel structure was intelligence, surveillance, and reconnaissance, ISR, anchored by the NEVA-AE Air/surface search radar system. This early Soviet-era system, though outdated, provided a critical low-altitude detection capability, warning Russian naval assets and coastal defenses of incoming threats, particularly low-flying cruise missiles or fast maritime vehicles. The Ukrainian objective was not simply damage but the complete, instantaneous systemic neutralization of this ISR node, thereby creating a temporary, critical blind spot for Russian forces operating near Snake Island. The mission profile mandated precision, speed, and a strictly asymmetrical allocation of force, pairing low-cost, expendable systems against high-value fixed infrastructure. At 7:55 Zulu, the engagement commenced. The NEVA-AE's rotating antenna, designed to detect targets as small as a surface skimmer, was suddenly saturated with multiple, rapidly closing low-RCS, radar cross-section, contacts. These were the vanguard of the attack, a cluster of tactical FPV UAS, each carrying a shaped 3-kilogram high-explosive anti-structure payload. These commercial off-the-shelf airframes, guided by remote operators hundreds of kilometers away, leveraged their extreme agility and low visual profile. On the Boiko Tower deck, the Russian defense was immediate but severely disadvantaged. Their primary anti-air countermeasure, man-portable and deck-mounted small arms, was insufficient against a multi-axis swarm utilizing erratic flight paths. The pilot objective for the initial wave of FPVs was explicit: achieve first strike blindness. One UAS, utilizing a high-speed terminal dive, successfully evaded small arms fire and detonated directly against the NEVA-AE's main antenna array. The resulting energy transfer shattered the fragile radar dome and permanently collapsed the antenna, instantly blinding the post. This was the most critical kinetic achievement of the entire operation. With the primary sensor system neutralized, the secondary FPVs pivoted to targeting/distraction protocol. They began engaging non-critical but structurally and psychologically disruptive targets, fuel bunkers, accommodation blocks, and communication relays. One FPV, intercepted by a last-second burst of rifle fire, still detonated close enough to ignite a localized fire on the deck near a fuel line, a tactical success in generating smoke and visual obstruction. This multi-axis FPV pressure immediately accomplished two tactical Ys: first, preventing the Russian personnel from re-establishing any alternative surveillance protocol, and second, drawing their limited attention and fire downrange, away from the true systemic threat. That threat, the Seababy Unmanned Surface Vessel, USV, was now closing at high speed. The Seababy is a 6-meter, twin-inboard motor platform engineered for long-range, high-mass terminal strike, carrying a warload approaching 1 metric ton of structural-grade explosive. The USV's approach was the primary decisive maneuver. Closing at sea level, its low-profile hull, designed to leverage sea clutter and the surface duct effect, made it virtually invisible to visual spotting until it was within a few hundred meters. At 8:05 Zulu, as smoke from the deck fires began to choke the Russian personnel, the Seababy transitioned into its high-speed terminal phase. Russian attempts to engage the USV with heavy machine guns were hampered by the lack of radar guidance, the high-speed lateral motion of the USV, and the continuous, blinding harassment from the FPV UAS overhead. The USV pilot, operating from a distant command post via satellite uplink, focused on maintaining a clean attack vector toward a single structural support column. Simultaneously, the Ukrainian controllers unleashed the final layer of their plan, a small swarm of miniature USV decoys. These smaller, faster vessels, mixed into the Seababy's wake, generated multiple confusion tracks, forcing the remaining Russian gunners to split fire wildly, wasting valuable ammunition on phantom targets. A high alert status was resolved by precise systems application. The Seababy utilized the momentary window provided by the smoke and distraction to close the final distance. At 8:18 Zulu, with the USV's onboard camera feed fixed on the chosen central leg, the critical load-bearing column, the unmanned vessel achieved its terminal phase objective. In the digital battlespace, information is the only hard currency. The resulting detonation was catastrophic. The explosive charge transferred its energy directly to the structural steel, resulting in an instantaneous structural failure that initiated a cascading collapse of the entire complex. Fireballs erupted as fuel lines ruptured, and the NEVA radar mast, already crippled, plunged into the sea alongside the shattered platform. The event concluded within 13 minutes of first contact, confirmed by the complete and permanent loss of all telemetry and video links. The confirmed outcome was the complete neutralization of the Boiko Towers ISR platform. The procedural success rests not on the amount of ordnance used, but on the imbalance of cost and effect. A tactical combination of expendable FPV UAS and one heavy USV, total cost less than a fraction of the targeted platform's value, achieved a strategically significant kinetic effect. The lessons learned underscore the vulnerability of fixed, high-value, high-RCS infrastructure when confronted by distributed, low-RCS, disposable systems operating in a coordinated swarm. This engagement proved that asymmetrical leverage can overcome static, traditional defenses, prioritizing systemic collapse over simple material damage. Modern conflict is increasingly defined by the operator's ability to seamlessly integrate diverse, unmanned platforms, a testament to the reliance on sophisticated systems, skilled remote piloting, and an ever-evolving concept of tactical control.